Welcome to Homework Lib.
Chapter 14, question 50. So they give us the sucrose concentration changing over time. And at part A, they're asking is the reaction first order or second order with respect to the sucrose. So there are two different graphs. This is for a first order reaction, and this is for a second order reaction. Say this is first and second. And the first order reaction is graphed for ln of the concentration at time t versus t, whereas second order is going to be 1 over at versus t. And over here, the first order, the graph is going to look something like this, a straight line going with a slope, negative slope. And second order is going to look like something like this with a positive slope. So I graphed these values, and instead of time minutes, you may want to just multiply this by 60 to get the times in seconds. And I graphed these two values, and it looks like a first order reaction. So we're going to rule out that it's going to be the second order reaction. In part B, they're asking what is the rate constant? So basically, this is going to be the integrated rate law where ln a t is divided by a 0, and this is going to be equals to minus kt. Now, instead of t, you can take 39 times 60. This is going to be the second value, and this is going to be the initial value. And if you solve for k, you get 6.1 times 10 to the power of negative 5 seconds. It's going to be part B. Part C, using this rate constant, calculate the concentration of sucrose at 33, 80, 140, and 210 minutes if the initial sucrose concentration is 0.316 and the reaction was zeroth order. So I'm just going to solve it for minute 36. I believe you can do the rest easily. So what we're going to do is to write the zeroth order integrated rate law, which is going to be AT equals to A0 minus KT. So they're asking for 39. So the concentration at 39, AT equals to A0, 0.316 minus the K is going to be this times 10 to the power of negative 5 times the T is going to be 39 times 60. And you're going to find AT to be 0.173. So this is for 39. And if you want to do that for 80 and 140 and 210, you simply solve for 80 again, but instead of this 39, you're going to write these numbers. Once you do that, you're going to find all the final concentrations if this was a zero total reaction.